Okay, let's continue on. Let's talk about vertical asymptotes. So in chapter, sorry about that. In chapter 7, we learned that an asymptote is a line that a graph approaches as x or y increases in absolute value. If a rational function has a non-removable discontinuity at x equals a, the graph of the rational function will have a vertical asymptote at x equals a. So only if it's non-removable. If it's removable, it does not have it. So here's a key concept. The graph of the rational function f of x equals p of x over q of x has a vertical asymptote at each real zero of q of x if p of x and q of x have no common zero, which means that means it's not removable. So if p of x and q of x have x minus a to the m and x minus a to the n as factors respectively, and m is less than n, then f of x has a vertical asymptote at x equals a. So let's go on to problem number 2. Alright, so if we take a look at problem 2, finding vertical asymptotes, it says what are the vertical asymptotes for the graph y equals x plus 1 over x minus 1 and x minus 3. Since 2 and 3 are zeros of the denominator and neither is a zero of the numerator or neither is a removable discontinuity, then x equals 2 and x equals 3 are vertical asymptotes. Let's look at let's do it on our own now. We have y equals x minus 2 over x minus 1 and x plus 3. So my discontinuities are at x equals 1 and x equals negative 3. They're neither one of them are removable, so those are also my asymptotes. Okay. Let's look at B. X minus 2, y equals x minus 2, and x minus 2 and x plus 3. Okay, so my points of discontinuity are x equals 2 and x equals negative 3. But as you can see, here is a removable discontinuity, so my only vertical asymptote is at x equals negative 3. Okay, let's clear the board and do the last one. So we have x squared minus 1 and x plus 1. We need to factor this. That's important, because that's going to help us determine if we have any removable discontinuities. And we do. So since we have that removable discontinuity and it's my only denominator, that means that this does not have any asymptotes. I hope this helps.